Welcome! Today we are diving into mensuration, which I know sounds a little fancy, but it's really just the practical math of measuring the world around us. From the floor plan of a house to the layout of a sports field, it's everywhere. And by the end of this, you'll have the exact tools you need to measure it all. So let's get right into it.
Have you ever actually stopped to think about questions like these? How much paint do you really need to buy for a wall? How much fencing are you going to need for a new garden? Or how does a city planner even begin to figure out how much grass to order for a brand new park? These are all mensuration problems, and today we're going to learn exactly how to solve them.
Okay, let's start with two of the most fundamental ideas. First up, we have perimeter. So what is it? It's simply the total length of the boundary of a shape. The best way to picture it? Think of it as the fence going all the way around a yard. It's a measurement of distance, plain and simple.
Right, so if the perimeter is the fence, then the area is the lawn inside that fence. See the difference? It's not about the distance around the edge, but the total amount of flat space or surface that's enclosed by that boundary. One is a line, the other is the space it holds.
All right, now that we have those definitions down, let's actually start using them on some shapes we all know. We're going to begin with the real building blocks of so many things we see every day, squares and rectangles.
So first, the rectangle. As you can see here, it's defined by just two key measurements. Its length, which we'll call L, and its breadth, or its width, which we'll call B. And that's pretty much all you need to know to get started. And here's the best part. The formula for its area is just so simple. You just multiply the length by the breadth. That's it. The big takeaway here is that with just two quick measurements, you can figure out the entire surface inside that shape. Okay, so what about a square? Well, a square is really just a special kind of rectangle, right? It's a rectangle where the length and the breadth are exactly the same. So we don't even need two different letters. We can just call the length of any side A. And because the length and breadth are the same, the formula gets even easier. The area is just the side multiplied by itself, or side squared. It's this beautiful simplicity that makes the square such a fundamental shape in math and even in design. Okay, let's put this into practice with a classic problem. You've got a rectangular field, and there's a path all the way around it. How do we find the area of just the path? Well, you break it down into a simple three-step process. First, you calculate the total area of the big outer rectangle, that's the field and the path together. Second, you find the area of just the inner rectangle, the field itself. And finally, you just subtract that smaller area from the larger one. Whatever's left over, that's the area of your path. And when you follow those steps, using the numbers from our source material, you get a final answer of 400 square meters. You see? It looks like a complex problem at first, but when you break it down into just two simple rectangle calculations, the solution is actually pretty straightforward.
All right, let's move on to our next shape and see how these ideas build on each other. We're talking about the triangle. It is one of the strongest, most important shapes in all of engineering and geometry. It's a true geometric secret weapon.
Now, the formula that most of us probably remember from school is this one. The area of a triangle is 1/2 of its base times its perpendicular height. So you take the length of the bottom, you multiply it by the straight-up height, and then you just cut it in half.
That formula is great, but what happens when you can't easily measure that straight-up perpendicular height? What if you're out measuring a triangular piece of land, and all you have are the lengths of the three sides? Do you just give up? No way.
This is where a real secret weapon comes into play, Heron's formula. It looks a little intense, I know, but it's brilliant. It lets you find the area using only the lengths of the three sides, A, B, and C. That S in the formula is just the semiperimeter. You add the three sides together and divide by 2. It's an incredibly powerful tool for real-world situations.
So let's just make this crystal clear. You've got two tools in your toolkit for triangles. Use the standard formula when you've got the base and the height. But when all you have are the three side lengths, Heron's formula is your absolute go-to. It's a perfect example of how in math, there's often more than one path to the right answer.
Okay, we've mastered squares, rectangles, and triangles. Now let's expand our toolkit and meet the rest of the four-sided family, the quadrilaterals.
So over on the left, you see our old friend, the rectangle. And on the right, a parallelogram. The easiest way to think about a parallelogram is just as a rectangle that's been sort of pushed over or tilted. The sides are still parallel, but the corners aren't those perfect 90-degree angles anymore. That tilt is really the key difference.
Now let's run through the formulas for the rest of this family.
For the parallelogram, our tilted rectangle, its area is just its base times its perpendicular height, not the slanted side. For a trapezium, which has one pair of parallel sides, you basically average the length of those two sides and then multiply by the height. And finally, for the rhombus, which is like a tilted square, the area is found by multiplying its two diagonals and then dividing by 2. Each one has its own little trick.
All right, we've spent a lot of time with shapes that have straight sides. But what about maybe the most perfect shape of all? Let's dive in and unlock the secrets of the circle and that magical, mysterious number, pi.
Let's just quickly break down the circle's parts. Every circle is defined by its center point, which we'll call O. The distance from that center to any point on the edge, that's the radius, or r. And the boundary line itself, we call that the circumference. With just these simple parts, we can measure any circle in the universe.
So what even is pi? Well, this quote from our source material explains it perfectly. If you take any perfect circle, I don't care how big or small it is, and you measure the distance all the way around it, the circumference, and then you divide that by the distance straight across it, the diameter, you will always get the same number, pi, which is about 3.14. Always. It's a fundamental constant of the universe, which is just wild to think about.
And that amazing number, pi, is the key that unlocks the circle's formulas. The circumference, which is like the perimeter of the circle, is 2 times pi times the radius. And the area, all the space inside, is pi times the radius squared. You notice how that radius, r, is the crucial piece of information for everything.
And check this out. Here's a perfect example of how these two formulas work together. In this problem, we only start with the circumference, 132 centimeters. So we use that circumference formula to work backward and figure out the radius. Then, once we know the radius, we can plug that number into the area formula to get our final answer. It's a beautiful two-step solution.
So there you have it. From simple squares and powerful triangles all the way to the elegant circle, you now have the fundamental formulas for measuring the 2D world around you. The area of your room, the perimeter of a park, the space on a round table, you have the tools. So I guess the only question left is, what are you going to measure first?